Guys, so in this lesson we're going to do 7.7. Now up on the screen you're going to see that it says 7.3 right now, and here's why. Back in 7.3, I want you to think back to when we were doing this. We had just learned how to FOIL. So right after the FOIL lesson, where we learned how to multiply, we talked about these special products of polynomials. And so one of them was, and I'll skip all the main part because we already did this lesson. We said whenever you have something written like this, there's a special pattern. You can square the first term, square the last term, and then multiply them together and double it. And that's how you get the middle term. Now, I also said you can definitely just FOIL it out, and that's going to work as well. But this pattern will help you when we get to the end of the chapter. That's where we're at today. The other pattern we did, similar, we said that if you find that you have, we'll look at letter B here, if you have two binomials that are exactly the same, the only difference is that one is positive, one has a plus sign and one has a minus sign, then you square the first term, you do the F part, you square the last term, and you put a subtraction sign between them, okay? I want you to keep that in mind because what we're going to do today is from the opposite direction. They're going to be giving us a polynomial in standard form, and we're going to talk about two special patterns, and they're actually really, really, really easy. And if you recognize these patterns, you're going to be able to get the answer in seconds. You don't really have to do much work at all, okay? And so the first one's called the difference of two squares pattern, which says that if you see that you only have two numbers, okay, that's going to be the indicator that this is the pattern we're using. You only have two terms and you're subtracting them. That's what difference means, subtract. And they're both perfect squares, meaning you can take the square root of both of them and get a number that's rational. It's not a decimal that goes on forever. Crazy, different, not repeating. Then the shortcut is the answer rather, is to just make it the square root of the first term, and then the square root of the second term. You do a plus sign, you do a minus sign. Now that seems very vague right now, but let me show you with this example. So this is what was given. Okay, you can look at all this middle part. For the time being, I'm just going to ignore that for the moment because I don't want to confuse you. But we can take a square root of x, we can take a square root of 9. There's only two terms, there's a subtraction, so that's going to be the indicator. The square root of x squared is x and x. The square root of 9 is 3 and 3. 1 plus, 1 minus, I'm done. Okay? So it's really important you understand this rule because you could you could factor this out, but it's going to be tricky because to think about, we don't have three terms and that's what we're used to. So let's just practice perfecting this pattern. So I look at the problem and I say, ooh, I can take the square root of x squared and I can take the square root of 25. Both of those are perfect squares. I can get a nice, neat value. I look at the original, it's being subtracted. So my answer is going to be the square root of x squared, which is x and x, square root of 25, which is 5 and 5, 1 plus, 1 minus, and I'm done. The order is not important in this case, okay? All right, let's try letter B. So here, this is a perfect square, this is a perfect square. So the square root of 4z squared is 2z, meaning when I say the square root, I'm thinking what number times itself equals 4z squared. So 2z times 2z is 4z squared. Square root of 1 is 1 and 1. Because there was a subtraction in there, I can do plus and minus. Now, if you're wondering how this works, that's what they're showing us here. But you can also just FOIL this out, and you're going to see it's going to get you back to the original, okay? Let's just try a couple of these. They're all going to be difference of two squares, meaning I'm subtracting the difference of two different square roots. So this one's going to be s plus 7, s minus 7. The next one, t plus 9, t minus 9. Here, now we're going to take it the exact order it's in. The square root of 16 is 4, so that's going to go first. The square root of x squared is x, so that goes second, and I do plus and minus, okay? So even though if you're thinking, wait a minute, that is not in standard form, meaning the greater degree is first, that's okay. Just take it the way it's given to you, okay? All right. Next, square root of 4g squared is, 2g and 2g. Square root of 25 is 5 and 5. Plus, minus, and you're done. This one, the square root of 36h squared is 6h. So that goes first. Square root of 121 is 11. And I put a plus and a minus, and I'm finished. If you put the minus first and the plus second, as we've seen before, that's perfectly fine. All right, the last one, 9 and 9, 7k, 7k, plus, minus. Okay, so that's called the difference of two squares pattern. Now, there's only one other pattern we're going to look at, and that's called the perfect square trinomial pattern. Again, we're looking for these perfect squares. So this time we're talking about a trinomial. So we're going to have three terms. Just for sake of ease, I'm going to look at this example portion here on the right because I think it's easier, especially virtually, to look at concrete numbers. All right, if I look at my value and I see that the first term is a perfect square, so I can take the square root of x squared, as is my last term, that's going to be like a little flag that maybe this is going to work, okay? So look how easy this is. These are all plus signs. Square root of x squared is x. Square root of 9 is 3. I put a plus sign between them and square the two terms. So really what we're saying is that this factors into x plus 3, x plus 3. If you would do FOIL, you get x squared plus 3x plus 3x plus 9, which obviously simplifies to x squared plus 6x. And that 9 term at the end. The nice thing with these is if you didn't recognize that this is a perfect square and so is this, you could just factor it like normal and you would get the right answer. This is just sometimes a little bit of a shortcut, okay? Let's try a couple, look at lists that are done and see what I mean. So when I look at this problem, I say, oh, this is a perfect square. That's a perfect square. Let's see if I go ahead and set it up. Square root of n squared is n. Square root of 16 is 4. Because these are both plus signs, I'm going to do plus and plus. And if I FOIL that, it worked. Now the one thing I should do in the end, though, is to write it like this, okay? We know that when we have the same thing squared, same thing times itself, we could just write that as squared. All right, letter B, same deal. This one, 4x squared is a perfect square, 9 is a perfect square. So I'm going to do the square root of 4x squared is 2x. Square root of 9 is 3. Now this one, because they have to add to give me a negative, that's why they're both going to be subtraction signs. So the end answer is 2x minus 3 squared. The reason I'm writing this step out is just because sometimes it's not, it's helpful to FOIL just to make sure it worked. Okay, again, if you just want to factor like normal, that's perfectly fine as well. I'm going to work through these. Feel free if you want to pause it, try them yourself, and then check your work. That's a great idea. But this one is going to simplify into x and x. Square root of 64 is 8 and 8. We have all plus signs, so this is a plus plus. So in the end, my answer is x plus 8 squared. The next one, we have p and p. Square root of 196 is 14. And we're going to do plus and plus. So in the end, it's p plus 14 squared. This next one we have r and r. Square root of 169 is 13. Because the subtraction sign here, it's minus minus. So r minus 13 squared. Moving on, we have a and a. Square root of 81 is 9. And it's a minus, so it's a minus 9 squared. All right, number 11, square root of 36c squared is 6c and 6c. Square root of 49 is 7 and 7. Both are plus, because this is a plus here. So it is 6c plus 7 squared. And for the last one, we're going to have 10x and 10x. Square root of 1 is 1 and 1. We're going to put a subtraction sign there, so we just get 10x minus 1 quantity squared. Now this pattern is really helpful for problems like 11 and 12, because if you were to do the algorithm, 36 times 49 is going to be really big. If you even did the x method, you have a lot of possibilities for what you could do first. for 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, not to mention the possibilities for 49. So that's where this pattern is really helpful. If you look at some things and you're like, whoa, that's crazy, then maybe this pattern will apply, okay? Alrighty, now this one, fractions, don't worry, it's not bad. We're gonna look and I say, ooh, ignoring for right now this equals 0. We'll come back to that. But square root of x squared, we can take that. Square root of 1/9, it's gonna be, what can I multiply times itself? Well, 1/3 times 1/3, multiply straight across, it's 1/9. So there we have it. It's gonna be x and x, 1/3 and 1/3, and then both plus signs. So my answer is x plus 1/3 squared equals 0. Now I brought that 0 back in because this problem says solve, okay? Not just factor, but solve. So that's why they have an equal 0. They can't ask you to solve if they don't give you an equal sign. So we've done this before. We're just going to set each of them equal to 0. Now the fact is that they're both the same, so we only have to set one equal to 0. I subtract 1/3. X equals negative 1/3, and that is my answer. So I don't want to stop at this point or this point. I want to make sure to take it all the way to the answer because I solved it. All right, we're wrapping it up. Let's take a look at these three. Now notice I changed 14 and 15 from what they said, just to give you an example of two other kinds. All right, so I'm going to look at 13. I look at this, now let's just say, this problem isn't written like this, but let's just say it said d squared equals 4d minus 4. And we've seen problems like this before. If you see where you have two things on different sides and not a 0 on one side, then it's your job to get everything on one side. So for instance, if I had been given this, now again, they started us with this problem, but if this is how it had started, then you would have to subtract 4d on both sides. You'd get d squared minus 4d equals negative 4. And then you would add 4 to both sides. So you would do the steps necessary to get everything on one side, okay? All right, in this case, it's already given to us that way, but I just wanted to go over that in case it ever isn't, okay? I think there's a handful of problems that I assign that don't have that set up, but we've done it before, so I just wanted to review it. Anyways, I'm going to factor this. This is a perfect square trinomial. I get d and d, 2 and 2. Both are subtraction equals 0. So this is really d minus 2 squared equals 0. I can set, d minus 2 equal to 0. I add 2 to both sides, so d equals 2. Now notice I'm only doing it once because they're exactly the same, so I don't have to set both of them equal. When we get into graphing, we'll see what that means when that squared is there, what that means with our graph, okay? All right, so 14 and 15, if you can rewrite what it said so that it says what I have on my screen. We're going to start in lesson 7-8 pulling everything together, so this is a little preview of that. But what we haven't had to do in this lesson yet is look for a GCF. And we want to remember that this is always the first step, okay? Now, they didn't do that in this lesson because we don't want to throw too much at you. But now that you have an idea of those patterns, let's see how that applies. So, for instance, if I look at 50y squared plus 120y plus 72, whew, those are big numbers. So we should always note big or small, look for a GCF. And I can pull out 2. So I'm going to get 25y squared plus 60y plus 36. Now, my first term is a perfect square. So is my last. So that actually saved me a lot of work. 2 times 25. Oh, this is going to break into 5y and 5y. 36 breaks into 6 and 6. And both are plus. Now, if I check that, it would work. Notice there's no equal 0, so that's my end answer. Okay. One more GCF problem to wrap it up. I can look here and pull out a 3. So I'm going to get 3 times 9m squared minus 12m plus 4. The 3 stays. The square root of 9 is going to be 3m and 3m. Square root of 4 is 2 and 2, two subtractions. Now in both of these, I can take them one step further. This one I'll write as 3m minus 2